Hello everyone, I am Akriti Chaubey, Civil Engineering student of Faculty of Engineering and Technology, Lucknow University. My topic for seminar is Slum Upgradation. So let's start. This presentation contains the intro part in which I would talk about what is slum. In the next slide, cause and scenario of housing condition in slum will be discussed. Further, I will talk about what is slum upgradation. After that, I will cover the technical aspects in a slum upgradation project. Furthermore, some low-cost construction techniques and some government schemes will be covered. Then, two case studies are presented and then the conclusion will be given. If you see a satellite view of any international airport, motel, high-tech industrial building, you will find nearby sprawled areas. What are these areas? Who are these people that work saliently in these industrial buildings for the city to function? These areas are the informal settlements, that is, slum. So, how can it be defined? A slum is heavily populated, urban informal settlement that is unfit for living. The graph shows the top 10 states with highest slum population in the country, in which Maharashtra is at the top. Below given are some characteristics of a slum defined by UN Habitat, that includes poor structural quality of housing, insecure residential status, that is insecure ownership of house, overcrowding, inadequate access to safe drinking water, inadequate access to sanitation and other infrastructure. Housing is one of the basic amenity for good quality of living. It was recorded that 30% of world population lived in urban area in 1950 and it was estimated that 66% of world population will live in urban area by 2050. The remarkable causes for urban poor to live in these slum areas are increased migration from rural to urban areas for basic economic opportunities, rapid urbanization, natural disasters, lack of equitable supply of land, shelter and services at affordable prices, and many more. These causes create bad roofing condition, overcrowding, lack of sanitation and access to basic infrastructure. To deal with rapid urbanization and unprecedented magnitude of shelter provision, several approaches had been made in past decades, such as slum removal or slum relocation, which has now been replaced with slum rehabilitation or slum upgradation. So, what is slum upgradation? Slum upgradation refers to the redevelopment of slum area to make it meet basic necessity for quality living, and this will contribute to country planning and urban planning. So, the main objective of slum upgradation includes improvement of basic infrastructure, mitigation of environmental hazards, building of social capital and institutional framework to sustain improvements, and few more are mentioned here. In this slide, major technical aspects of slum upgradation has been covered. The first is site investigation and forecasting. Site location and condition is studied with the application of GIS and remote sensing, and population forecasting is done. After that, the type and structure of settlement and growth pattern is studied. The second is infrastructure and transport planning, which include infrastructure designing, control and management of water, sanitation and stormwater, solid waste management, transport, infrastructure, its design and management. For housing, material and technology are selected in such a way that it is cost effective, eco-friendly and has component of natural here-ness, which will contribute to intelligent building and construction. In the cost and quantity estimation, computations of materials are done. The life cycle costing analysis is conducted and the project cost is predicted. Now, let's see low-cost construction techniques for slum rehabilitation. Prefabrication. Concept of prefabrication has been adopted for speedier construction, better quality component and saving in material quantity and cost. Some of the construction techniques and materials for walls, roof and floor slab are as follows. In walls, first is fly ash, sand, lime bricks. It possesses adequate crushing strength, uniform shape, smooth finish and does not require plastering and also are lighter in weight than ordinary clay bricks. The second is solid concrete and stone blocks. This technique is suitable in areas where stones and aggregates for the blocks are available locally at cheaper rates. Innovative techniques of solid blocks with both lean concrete and stone have been developed for walls. Third is non-erodible mud plaster. The plaster over mud walls gets eroded during rains, which necessitates costly annual repairs. This can be made non-erodible by the use of bitumen cutback emulsion containing mixture of hot bitumen and kerosene oil. The maintenance cost is low due to enhanced durability of mud walls. In floor and roof. Some of the prefabricated roofing or flooring components found suitable in many low-cost housing projects are mentioned below. Precast RC plank, precast brick panels, trapezoidal panel roofing, etc. Some of the government schemes for slum upgradation is mentioned in this slide, which are Valmiki Ambedkar Awas Yojana, Jawaharlal Nehru National Urban Renewal Mission, Affordable Housing in Partnership, Rajiv Awas Yojana, Pradhan Mantri Awas Yojana. Pradhan Mantri Awas Yojana is the ongoing one. Its current status data is presented here. Now moving to the case studies. First is impact of slum rehabilitation project in Bangalore city. This is a case of Pandrepalya. This project was selected under Jawaharlal Nehru National Urban Renewal Mission project. Private consultants were engaged to prepare detailed project report. Estimates were prepared and approved in 2011 with an estimated cost of 261.17 crore rupees. The plot area was 21,150.3 square meters. The fixed area ratio obtained was 1.74. Here the residential area was 43.5% of the total plot area. In this project, RCC frame structure with non-solid cement blocks for non-load bearing walls were adopted, which are light in weight and has low cost of production. RCC door frames were adopted since it is eco-friendly, fire-resistant, termite-proof and has longer life. Mild steel door for rooms and PVC doors for toilets and bathrooms were adopted. Steel glazed windows and ventilators were adopted for its cost effectiveness. Whitewashing for internal painting, waterproof cement base for external painting and cement concrete flooring specifications was followed. This resulted in 100% of households felt locality is safe. Quality of housing improved, but there was dissatisfaction in terms of sustenance and maintenance. Moving to the next case study. This case study is about Aranya low-cost housing in Indore. The total built-up area was 10 hectares. The project cost for this was 100 million. This project got completed in 1989. The objective of this was to improve and upgrade the existing slum area, to provide service sites for new housing developments instead of building complete houses, to provide 6,500 residential plots ranging in size from 35 meter square for EWS to 475 meter square for high income groups. The funding for this project was 100% from local sources. In this, the residential area of total area was 58%. Project implementation. Let's first see construction details. Foundation. Since soil was black cotton soil, cast in situ under rimmed piles in concrete were used. Structural members used were reinforced concrete plinth beams, load-bearing brick walls, reinforced concrete slabs. Services site and service approach. Each family was provided with a plot having water tank, sewerage connection, paved access with street lighting and storm water drainage. Houses were clustered in groups of 10. Septic tank was provided for every clusters. Water was drawn from 3 local reservoirs, and to economize 20 toilets are connected to one manhole. This image shows the path of light source, that how it will shade the street. The building height to street width clusters ratio is such that the streets are shaded except when the sun is overhead. Sewerage system. Sewerless sanitation was adopted. The soil being impermeable black soil of 2 meter depth, conventional sewerage system was adopted. It was designed after thorough analysis of topography. Higher income groups using more water were located at high ground level to generate large flow. Lower income groups using less water located at lower ground level. This resulted in 10 to 15% savings. Treatment system. For conveyance system, a wet well and lift station was constructed near the final manhole. Oxidation pond was constructed such that it was located on northwest corner of the site. Since it is simple in operation and effluents were suitable for disposal. Storm water drainage system. Combination of underground and surface drainage system was designed. Underground used for wider roads and surface drainage used for internal roads, which was very efficient and facilitated healthy and clean living. It understood the traditional Indian habits. Planning and designing was in accordance with the prevailing socio-economic and technological condition. This project adopted cost-effective construction material and techniques. In this, planning was whole to part, that is from township level to dwelling unit level. Accessibility has been an essential factor for designing in this project. Staggered road prevented thorough traffic and reduced speed of vehicles. It had climatic responsive and site responsive design. So, summarizing here, besides improving the slums, the causes of slum creation should be addressed. Strategic planning and intelligent design and construction will fill the need. Levels of infrastructure provision should be based on community priorities, affordability, and component of natural nearness. Ending with B.V. Doshi's quote, "Design is nothing but a humble understanding of material, an instinct for solution, and respect for nature." These are the references I used in this presentation.
Thank you.